Okay, this is going to be our first video in talking about how to do some basic statistics with Minitab Express. What I want to do here is go over how to find normal probabilities, how to find normally distributed random variables given probabilities, and we want to talk about the central limit theorem all within Minitab Express. So as you follow along with the lecture, make sure you have Minitab Express open. All right, and what you'll notice here with the software, just briefly, is that down here we get what looks like spreadsheet software, looks like Excel, and we're going to have eventually maybe a column heading. We could call this baby weight, and under that I'll typically be giving you values. So here's an example of two babies and their appropriate weight. If you do not see this view, you can click under view and make sure that you have data on bottom checked. All right, PC users, please note I am working off a Mac and your view looks just a little bit different. So if you ever have a question with Minitab Express, you can't find something, just shoot me an email or post the question in Course Cafe on Blackboard, which would actually be a little bit better because then other PC users can quickly respond. All right, so let's get started here with reviewing the normal distribution now with Minitab Express. All right, and if you watched some of the review lectures, you noticed that I always used Excel. That's what I used to teach with. And you know, what I suspect you'll say in about 20 or 30 minutes is, wow, Minitab Express is quite a bit easier to use than Excel. All right, so and as a side note, I have typed out all of these instructions and directions and placed them in your Minitab folder in Blackboard. All right, so let's get started here. So what we want to do is we want to find areas or probabilities, and there's three different ways we can do this. All right, and the first one here is we can find what's called the cumulative area. The cumulative area is the area to the left of the value as you see in the picture below. All right, and we're going to work simultaneously with two different examples throughout this lecture. We're going to work here with what is called the standard normal distribution, as you should recall from the review lectures, and this is where we have z-scores with a mean of 0 and a standard deviation of 1. So get used to this notation here. This is something I use regularly. This is saying that we have z-scores that are, the n means normally distributed with a mean of 0 and a standard deviation of 1. All right, and so for our first problem here, what we're reading here, what is the probability that z is less than negative 1.2? All right, so we want to find the probability that z is less than negative 1.2. So over here in Minitab, we are going to go under probability to distribution plot. Okay, and under distribution plot, we are going to select display probability. All right, and notice here the first thing we come to is a drop down. And in this drop down, normal is the default, and normal is what we are going to be using. In the span of the course, we will also use what is called the t distribution. We will also use the f distribution. Many of these other distributions come up in a graduate stats course. But once you have normal distribution selected, you need to put in the mean and standard deviation for that particular normal distribution. Well, as you can see, we're doing the standard normal, which is the default, a mean of 0 and a standard deviation of 1. So we can leave the mean and standard deviation alone. All right, and now it says shade the area corresponding to the following: a specified probability or a specified x value. Well, what we have here, this negative 1.2, is a z-score, so that's an x value. So we need to select a specified x value, and then we need to click on the picture of which probability we want. Do we want the probability to the right? Do we want the probability to the left? Do we want the probabilities in equal tails? Or do we want the probability in the middle of two different values? And the answer here is we clearly want the probability that z is less than negative 1.2. So we choose left tail and type in our z-score of negative 1.2 and say OK. Now notice what we have here. If you've ever taken any other stats course, you usually had to sketch these yourselves, but we are now with software and we get the picture from the software. And so what we're saying here, the probability that z is less than to the left of negative 1.2, and the software returns this long decimal number. Now, I am going to ask you on the quiz and on the exam to write this as a percent rounded to the 100th place. All right, so that means moving this decimal place to the right 2 times, so we get an 11 point. All right, and then we have a 5070, and we want to round to the 100th, which is that first 0 spot, so we look to the right at that 7, and that 7 rounds the 0 up to a 1. So our answer here is 11.51%. All right, let's do another one. Let's find the probability that z is less than 2.3. Now, a lovely trick you have in Minitab is, well, let me start over by saying what we can do is go back to probability, distribution plot, display probability, and we get back to our input screen. But one of the things I recommend is use a shortcut when available, and that is if your mean and standard deviation aren't necessarily changing, meaning everything stays the same here, we're just changing the given z-score from negative 1.2 to 2.3, what we can do is click on Make Similar right here at the top of our window. And what we get here is the input screen from the last problem, okay? And so we have a normal distribution. It's standard normal with mean 0, standard deviation 1. We are given a z-score, all right? We want the probability to the left, but now instead of to the left of negative 1.2, we want to the left of 2.3. So we click on that. And notice here we get our picture. All right, so everything to the left of 2.3 is shaded. And we have our decimal that we now need to write as a percent rounded to the 100th. So we'll have 98.93 because the 7 rounds the 2 up. All right, so again, we get 98.93%. All right. So there we have finding probabilities to the left of z-scores. All right, z-scores don't come up as much now as they used to because of software, and I really think this stuff starts to make sense with you guys when we're working with numbers that mean something. So let's work with IQ, all right? Because if I say an IQ of 70 or if I say an IQ of 140, those numbers have some qualitative value to you. You know the difference between a 70 IQ and a 140 IQ. All right, so IQ happens to be normally distributed with a mean of 100 and a standard deviation of 15. All right, and for our first problem here, we want to find the probability that IQ is less than 78. All right, so we want to go into probability, distribution plot, display probability. All right, and now we're no longer working with the standard normal. We have a new mean and standard deviation. So we need to put in 100 as our mean and 15 as our standard deviation. We are given an IQ value of 78, so we say a specified X value. We want less than 78, so we choose left tail and type in 78 as the respective IQ. All right, and our picture is correctly shaded to the left of 78. All right, and we get our decimal that we need to convert to a percent rounded to the hundredth, and that's going to be 7.12%. All right, so we come over here and write 7.12%. All right, let's do the same thing, but now with an IQ less than 112. So we can go into make similar. Mean and standard deviation stay the same. We're given an IQ. We want less than that IQ, but the IQ changes to 112. All right, and again, we would see our picture with everything shaded to the left of 112, and our percent is 78.81%. Okay, we only look at the 4. The 4 does not round the 1 up, so it stays a 1. All right, so we have found probabilities to the left of values. Now we want to find probabilities to the right of the value. All right, so let's start here going back to the standard normal distribution. All right, so we want to find the probability that z is greater than negative 1.4. So we go into probability, distribution plot, display probability. We're back on z-scores or the standard normal, so our mean and standard deviation stay as the default 0, 1. We are given a z-score or x value, but now we want the greater than probability, which is right tail, and we simply type in negative 1.4. All right, and now again we see everything to the right of negative 1.4 is shaded, and we want to write this decimal as a percent rounded to the hundredth, so that would be 91.92%. All right, let's do another one using make similar. All right, mean and standard deviation stay the same. We're given a z-score. We want the greater than probability, but now we are looking at 1.94. We say OK. We see everything shaded to the right of 1.94, and that probability is 2.62%. Okay, now let's switch to IQ. All right, so we go into probability, distribution plot, display probability. All right, and we are back to our 100 mean and our 15 standard deviation. We are given an IQ, so an x value. We want greater than, which is right tail, and our IQ of interest is 82. We say OK. All right, and we see everything shaded to the right of 82, and that probability is 88.49%. Okay, we can do the same thing for 123. Changing the IQ only changes the x value down here. We say OK. Everything to the right of 123 is shaded, and that percent is 6.26%. Okay. Now, here's a follow-up question I can ask. How many people do you expect to have an IQ greater than 123 if we have a random sample of 500 people? Well, your first thought is, well, I don't know exactly how many people, but what I do know is 6.26% of them. So the question becomes, can we find 6.26% of 500 people? Absolutely. I will do that calculation for you in Excel here. All right, and of course you can use your calculator to do this. We just want to multiply the decimal by how many people we have. All right, so we'll say equals 0.0626 times 500, and we get 31.3. Now we have a problem because you don't want to answer the question as 31.3 people, right? Because what does 0.3 of a person look like? So how do we round? And we actually have to round carefully, all right, because we need to think about this. To have 6.2%, we have to have that 0.3 of a person. And if we have to have that 0.3 of a person, then what we're going to do is round up. So in this problem, all right, so in this problem, we are going to round up 31.3 to 32 people. Okay? All right, let's take a look at our third type of area, and that is the area between two values. All right, so we can minimize Excel here and go back to Mini-tab, and now we want to find the area between these two z-scores of -1.2 and -0.4. So we go into probability, distribution plot, display probability. Again, we're back to our 0, 1 mean and standard deviation. Now we are actually given two z-scores, all right? And so intuitively, which picture do you think you're going to select? And what I hope you're saying is the middle, all right? And does order matter here? Absolutely. Notice the order on the x-axis, all right? x1 is the smallest value, and x value 2 is the larger value, all right? So we start by typing -1.2, and then our x value 2 is -0.4. Right? We say OK, and notice we have the area shaded between these two negative z-scores, and we get a probability of 22.95%. Okay, we can do the same thing for the two positive z-scores here, so we go into make similar, and we change our z-scores to 0.28, the smaller one, and then 1.68, the larger one. And we see we have the area shaded between these two z-scores, and we get that probability as 34.33%. Okay, let's switch over to IQ scores. So we go into probability, distribution plot, display probability. We now have a 100 mean and a 15 standard deviation. We are given two IQ scores, 76 and 98, and we want the area between them. We start by typing in our smaller IQ and then our larger IQ, and we say OK. Again, notice the area between them is what's shaded, and we get that probability as 39.22%. Oops, and I missed the point. There we go. All right, let's do the same thing for IQs of 102 and 128. So we change our smallest to 102 and our larger one to 128 and say OK. And what we see here is a probability of 41.60%. Okay. Now, as a follow-up question, how many people do you expect to have an IQ between 102 and 128 if we have a random sample of 500 people? And what you say is 41.6% of them. All right, so we need to find 41.6% of 500 people. All right, so we take equals 0.4160 times 500, and we get an integer of 208, and that is our answer. Okay. Now, minimizing Excel again, let's flip this process. All right, now we actually want to find values. So what's changing? Well, now you will be given a probability and will be asked to find the appropriate value of the random variable. Okay, what's important is that you will still need to input the mean and standard deviation. Okay, sorry, we had a knock at the door. You will still need to input the mean and standard deviation for the distribution, all right, as we did before. And what you're going to notice is that really only one aspect changes in Mini-tab, all right? So let's be on the lookout for what's actually changing, all right? One thing that is very important, and this is going to probably cause some of you to miss some points on the quiz this week as well as the first exam, and that is you have to be careful when rounding values given the probability. Okay, and the trick is always round into the shaded region. All right, so what do I mean by that? Values on the left of the distribution round down in order to round into the shaded region. Values on the right of the distribution round up in order to round into the shaded region. All right, so you need to be careful here. And again, we're getting ready to go through a whole bunch of examples, so I think you guys are going to catch on pretty quickly. All right, let's start with what happens when you're given the area to the left. All right, and we're going to go back to the standard normal distribution, and what we see here in this first problem, what it's asking, all right, in statistical shorthand, what is the probability of z less than some z-score, all right, that equals 69.54%. All right, so again, life's on repeat here. We go into probability, distribution plot, display probability. All right, we've got our standard normal distribution, so mean and standard deviation are the default. All right, and here's what changes, guys. We are no longer given a z-score. What we are given is the probability. So we leave a specified probability selected, okay, and we are given the area to the left. So this is a left tail problem. And then we simply need to type in what that probability is. So I type in 0.6954. Notice it has to be a decimal, all right, not as a percent. And we say OK. All right, and we see everything shaded to the left, and we see what we inputted, which is the given probability. And what we are looking for as our answer is on the x-axis, and this is the correct z-score. All right, and what we want to do here is round this z-score, all right, to the 1,000th place. All right, and so what that means is regardless of what this 2 is, okay, regardless of what's there, this rounds down and stays as 0.511 because we're rounding into the red area. All right, so again, our answer here is z equals 0.511. Okay. For our second problem, all right, we want the area to the left of z is 14.35%. So we can go into make similar. Our mean and standard deviation stay the same. We are given a probability to the left, and that probability is 0.1435. All right, so again, notice how I have to convert the percent, and I say OK. All right, so again, we want to round to the 1,000th, okay? And so even though you're going to think, oh, that 7 rounds that 4 up and because we're rounding down into the shaded region, all right? And so our answer is actually negative 1.064, okay? All right, because think about it. If we round it up to negative 1.065, notice we're no longer in the red region, right? We're no longer here. We're in the white region, all right, which is what we don't want. All right, let's switch over to IQ scores. So we want given the probability that the IQ is less than some IQ is 38.4%. So we go into probability, distribution plot, display probability. Now we have a mean of 100, a standard deviation of 15. We are given the probability, all right, it is to the left, and that probability is 0.384. We say OK. All right, and it gets a little blurry in there, but what we see is that IQ, and I'll call it IQ, is 95.575. Okay, all right. Now, this next question is typically how it will be worded. All right, so let's make sure that you know the key words to pay attention to. What is the highest IQ that will put the person in the bottom 4% of the distribution? All right, ignore highest, guys. All right, what's important here is the word bottom. All right, that's bottom is the left side of the distribution. The word top signifies the right side of the distribution. All right, so what we're given here is bottom 4%. All right, so we have our mean and standard deviation for IQ. We are given a probability. We're given the bottom, which is left tail, and we simply type 0.04, all right, or 4%. We say okay. All right, and if we are rounding this IQ to the thousandth, we just ignore this 7, and our answer is 73.739. Okay. All right, let's keep moving forward. All right, let's talk about what happens when you're given the area to the right. All right, so let's go back to the standard normal distribution, and now we want to find the z-score that has 56.21% shaded to the right of it. So we go into distribution plot, display probability. We're back to standard normal, which is 0, 1. We are given the probability. It is now right tail, all right, because our sign says greater than, or what I like to say is it points to the right. And we need to change the probability to 0.5621, and we say okay. All right, and unfortunately, we are not going to be able, and this sometimes happens. All right, so what I see here, and if you squint, you might see it too, is negative 0.156296. All right, now we're dealing with the right side of the distribution. All right, and if we want to round this to the thousandth, then we're looking at this 6. All right, we don't necessarily look at what's next to it. We are always going to round this 6 up because we're rounding into the red shaded region. And so our answer here is z equals negative 0.157. Okay, again, rounding up into the right. All right, let's do another one. The area to the right of z is 1.23. So we go into make similar. We have our standard normal distribution. We have a specified probability. All right, we want to the right, and our percent of interest is 1.23%, so 0.0123. We say okay. And our appropriately rounded z-score here is 2.248. All right, that 7 rounds up. I don't even look at the 6. I round that 7 up to 8. Okay, let's switch over to IQ. All right, so let's go into probability, distribution plot, display probability, change our mean to 100, our standard deviation to 15. We're given a probability, again here, IQ greater than, so to the right. And we put in the probability of 0.763. We see everything shaded to the right of this IQ score. And what is that IQ score? All right, now be careful here. We got to round it up, so it's 89.261, okay, because we have to round into the shaded region. All right. What is the lowest IQ that will put the person in the top 2% of the distribution? All right, so top 2% is a right tail problem. We just need to change the probability to 0.02, and we say okay. All right, and we get that IQ appropriately rounded is 130 and we're given here to the thousandth place, so there's nothing to round. If we wanted to round it to the hundredth, it would be 130.81. Okay, so just keep that in mind. If we wanted to round to the integer, it would be 131. Okay. All right, so let's move on into the central limit theorem. All right, so just to review one more time, one of two conditions must be met to use the central limit theorem, and that is that either the population is normally distributed, like we have seen with IQ, or the sample size is at least 30. Okay, so either of these conditions work, but we do have to have one of them. All right, so assuming that one of these conditions is met, what changes and what stays the same with regards to the distribution? And the answer is the population mean mu stays the same. It does not change. Okay, so like we've seen with IQ, if we start taking random samples of people and getting an average IQ, all right, and let's say we're taking random samples of size 20 people, all right, the mean of that distribution of samples of size 20 people is the same as the population mean of 100. Okay, what about the standard deviation? The standard deviation of the sampling distribution does in fact change. How does it change? Well, the new standard deviation for the sampling distribution is equal to sigma, the population standard deviation, divided by the square root of n. And folks, this is what's changing in Minitab. You have to calculate this new standard deviation on your own. I do not give it to you, all right, and it is greatly going to affect the probabilities, all right? It's making the standard deviation much smaller than the original one for the population. All right, let's see a few examples. All right, so keywords in the problem. You will be asked to find the probability of the sample mean. So you're looking for the words sample mean in the problem. If you don't read sample mean, then you don't change the standard deviation. All right, you will also be given a sample size. For example, given a random sample of 20 people, what is the probability that the sample mean IQ is less than 92? All right, well, if you're not thinking about it and you just go straight away to Minitab, to distribution plot, display probability, and you know you have to put in your mean and standard deviation, you can, according to the central limit theorem, you can put in your mean of 100. But when it comes to the standard deviation is no longer 15. The new standard deviation is 15 divided by the square root of 20. All right, so either by Excel or calculator, we need to calculate this number. So I'm going to say equals 15 divided by the square root of 20. All right, and I'm just going to copy this and paste that into Minitab Express. All right, we are given an IQ score of 92, so that's an X value. I want the probability that the sample mean, so notice we see our words, sample mean, is less than 92, so I choose left tail and type 92. Okay. All right, and we see down here our probability is 0.854%. All right, so 0.854% is our very small probability. All right, let's do the same thing, but with a greater than. All right, so now given a random sample of 20 people, what is the probability that the sample mean IQ is more than 110? All right, and this is where make similar so nice because none of us want to retype that standard deviation. We can just go into make similar. But we now have a right tail problem because it specifically says more than. And we change our IQ to 110 and say OK. All right, and we get this very small probability, 0.143%. Okay, and that is our review of the normal distribution with Minitab Express. And in the next video, I'll be going over some classwork problems, which I think is where you're probably going to want to try to do some stuff on your own, pause the video, and then get an explanation from me. And by that point, you should be ready for the homework.